Every USB-C cable you own has a tiny brain inside it, and every single time you plug it in, your devices have a secret conversation you never hear. Most people think USB-C is just a plug. You stick it in, it charges your phone, maybe moves some files. We're talking about 24 pins having full-on negotiations, switching roles on the fly, and even rerouting signals depending on which way you plug the cable in, all in less than a second. USB-C is a 24-pin reversible connector that was first designed in 2012 by Intel, Apple, Microsoft, HP, and the USB Implementers Forum. The connector itself is about 8.4 millimeters wide and 2.6 millimeters tall. Now, here's where it gets interesting. Those 24 pins aren't random. They're split into two rows, row A and row B, and they're arranged in a mirrored layout. That mirror design is exactly why you can plug a USB-C cable in either way, and it just works. The connector doesn't care about orientation because the pins on one side are a reflection of the pins on the other. But what do those 24 pins actually do? Let's walk through them. There are 6 types of pins inside a USB-C connector, and each one has a specific job. Let's start with VBus and GND, the power pins. There are 4 pins each. VBus carries power, and GND provides the ground return path. By default, VBus runs at 5 volts, but, and this is important, that voltage can be negotiated up, way up. With USB power delivery, VBus can go as high as 48 volts and carry up to 5 amps. That's up to 240 watts of power through a single cable. Next up are the D+ and D- pins, the USB 2.0 pins. There are 2 D+ and 2 D- pins on the connector. These pins exist for backward compatibility, so your USB-C port can still talk to older USB 2.0 devices at up to 480 megabits per second. The TX and RX pins carry data. There are 2 TX pairs and 2 RX pairs, 4 high-speed lanes in total. Each lane can push up to 10 gigabits per second or more, and with USB 4, all 4 lanes working together can hit 40 gigabits per second. The configuration channel pins, CC1 and CC2, are the brains of the entire operation. They detect when a cable is connected, figure out which way the cable is oriented, negotiate how much power to deliver, and set up which data protocol to use. Honestly, CC1 and CC2 are the most important pins on the entire connector, and we'll talk about them a lot more in a minute. Finally, the sideband use pins, SBU1 and SBU2. These are lower speed signal pins that only get used in special modes, like when your USB-C port is sending a DisplayPort video signal or running Thunderbolt. They carry extra data that doesn't fit on the main lanes. So those are the 24 pins: power, ground, legacy data, high-speed data, configuration, and sideband. I hope you learned something new. See you on the next one.